Welcome to this explainer. Today, we're cutting through the noise and distilling concrete construction science into a high-stakes masterclass. This is specifically designed for you, the site leaders, project managers, and supervisors, especially those of you operating in demanding, incredibly hot climates like Pakistan. We're getting right to the point, how to actually control the pour on site so your foundation lasts a lifetime. Let's dive in. Here is our game plan for today. We'll be hitting 6 key areas: myth busting, drying versus curing, the water cement golden rule, the skeleton and muscle of your mix, managing hydration in hot climates, the secret sauce of admixtures, and finally, strict on-site quality control. All right, section 1, the big myth, drying versus curing. Look, the biggest, most dangerous myth out there on the job site is that concrete needs to physically dry out to gain strength. Honestly, that is completely false. Concrete actually needs to cure. And curing is a chemical reaction called hydration. The literal second water hits that cement powder, the water molecules bond with the cement particles to form this incredible glue, calcium silicate hydrate. Drying? Well, that's just the physical evaporation of leftover surface moisture so you can eventually paint it or lay flooring. But curing? That is the chemical magic that gives you real structural strength. So why is curing the most ignored step in construction today? Well, it's because of that exact drying myth. If we mistakenly think concrete just needs to air out and dry, we leave it fully exposed to the harsh sun and wind. We try to rush the process. But by doing that, we are literally sabotaging the structural integrity of the entire project from day one. Here is the bottom line. If water evaporates from your slab too quickly, that vital chemical hydration reaction just stops, dead in its tracks. It's a premature halt. And what are you left with? You're left with weak, brittle concrete that's absolutely plagued by surface dusting, scaling, and severe shrinkage cracking. It's a nightmare. That is exactly why managing moisture, whether that's through wet curing or sealing compounds during those critical first few days, is simply non-negotiable. Moving on to section 2, the water cement golden rule. This right here is the golden rule of concrete engineering. As a site leader, this is the most critical technical point you need to ruthlessly enforce. You have to maintain an optimal water-cement ratio. By weight, this usually lands somewhere between 0.40 and 0.60. Hit that sweet spot, and you guarantee your structural integrity and serious long-term durability. We've all seen it happen on site, right? The supervisor turns their back for 2 seconds, and a crew member sneaks in a little extra, unauthorized water just to make the concrete flow better. But listen, that extra, unmeasured water isn't doing any chemical work. It's not hydrating anything, it's just taking up space. And when it finally evaporates, it leaves behind a massive network of microscopic pores deep inside the hardened structure. Bumping that ratio even slightly can literally slash your 28-day compressive strength by 15 to 20%. Not to mention, it causes your heavy aggregates to sink, which we call segregation and bleeding, and leaves your concrete highly permeable and completely vulnerable to future water damage. Section 3. The skeleton and the muscle. To really grasp why that structural degradation happens, think of your concrete mix like a human body. The aggregate, your gravel and sand, that's the skeleton. It provides the raw, sheer strength and takes up a massive 60 to 80% of the total volume. Then you have the cement paste, which is just your cement powder mixed with water. That paste is the muscle. It's the glue that completely coats the skeleton and locks it all firmly together. Because that aggregate makes up the vast bulk of the volume, your long-term durability relies entirely on the soundness of the skeleton. If you cut corners and use poor quality sand packed with high silter clay content, you are instantly introducing weak points. That compromised soundness is going to guarantee long-term cracking, and it honestly won't matter how expensive or high quality your cement paste is. The skeleton itself has to be rock solid.
All right, section 4, hydration in hot climates.
So what actually happens to this delicate balance of skeleton and muscle when you're pouring in extreme heat, like what we constantly deal with in Pakistan? Well, when ambient temperatures soar, that exothermic hydration reaction, the chemical process that naturally generates its own heat, goes into overdrive. Temperatures inside the core of the concrete can easily spike to 160 degrees Fahrenheit. This excess internal heat makes the concrete expand rapidly. Then, if the surface cools faster than that boiling hot core, the concrete contracts unevenly. It's a violent push and pull that causes disastrous thermal cracking straight through your foundation. Which leads us perfectly into section 5, the secret sauce, admixtures. Instead of letting the crew dump in unauthorized water just to get better workability, modern commercial projects rely on precision chemicals. First up, you have plasticizers or superplasticizers. These are an absolute game changer. They give you self-leveling, highly flowable concrete without adding a single extra drop of water, period. And second, we have retarders. These are essential for hot climates because they delay the setting time. This stops the concrete from flash setting inside the truck during a long transport or right in the middle of a massive continuous pour.
The chemistry behind how these superplasticizers work is basically molecular magic. Normally, when water hits cement, the particles naturally want to clump together into flocks, and they trap water inside. But superplasticizers coat those particles in polymers that give them all a similar electrical charge. Think of two identical magnets. They repel each other, right? This electrostatic repulsion physically forces the cement particles apart, releasing all that trapped water back into the mix. You get drastically improved flow, a higher slump, and way easier pumping, all while keeping that water-cement ratio locked down tight and completely safe.
Finally, Section 6, On-Site Quality Control. To guarantee that all this chemistry and physics is actually working on the ground before a single drop is poured, strict quality control is non-negotiable. And the ultimate field test for any site supervisor is the slump test. You absolutely must ensure that every single batch rolling onto your site matches the project's specific engineering requirements before you even think about accepting it. It's a very strict, highly repeatable three-step procedure. You fill the standard cone in 3 equal layers, tamping it 25 times each layer to knock out any air pockets. Then, level the top and pull the cone straight up. Finally, you just measure the downward slump drop distance. It's a simple physical test, but it instantly identifies the exact real-world state of your mix. Interpreting it is straightforward. A low slump drop means you've got a stiff mix, perfect for high-strength pavements. A medium drop is your standard for normal reinforced work. But here is the kicker. If you pull that cone and see a highly fluid slump of over 100 millimeters, but you know for a fact there are no superplasticizing chemical additives in that batch, your mix is fatally wet. The water-cement ratio is blown, the structural integrity is totally compromised, and you need to send that truck away immediately. So as an informed site leader who just sat through this explainer, the choice is yours. Will your next pour rely on precision chemical science, proper hydration, and modern admixtures? Or are you going to let the dangerous myths of drawing and unauthorized water dictate the ultimate fate of your foundation? Protect the pour, enforce the science, and your structure will stand the test of time. Thanks for joining me.